Algebra 2 skills number 22, we're going to look at something called the leading coefficient test. The leading coefficient test is a way to see what happens to a graph as it leaves the screen, so to speak, or as it heads off towards infinity in both directions. To apply the test, we're going to look at the degree and leading coefficient. In the degree, we're going to see if it's even or odd, because remember that if it's a polynomial function, the whole variable exponents have to be whole numbers, and all whole numbers are either even or odd. And then we're going to look at the leading coefficient as positive or negative. The leading coefficient, it just has to be a real number. It could be anything. It could be the square root of 2 or pi. So it may not be even or odd, but we're going to see if it's positive or negative. And we have 4 possibilities. Remember, this is the degree, either even or odd. This is the leading coefficient, either positive or negative. And that makes for 4 possibilities again. If it's even positive, then the graph is going to be up on both sides, on the ends of the graph. If it's even and negative, it's going to be down on both sides. If it's odd and positive, down on the left, up on the right, and odd on the negative, the opposite. A way that I like to remember this is to use the acronym EAT, like you're eating a sandwich or something, EAT, even arrows together, is a good way to remember that, because if you notice the 2 evens, the arrows are together, they're going the same direction. And then common math sense says that positive is going to go up, negative is going to go down. And it stands to reason that if even arrows are together, then odd arrows will not be together, and your positive hand would be your right hand. That's the one that goes up, because positive is right in math, and then negative, the left hand goes up. So that's a little way I use to remember those. For even positive, and for all 4, we're just going to illustrate with even positive. There are different ways you'll see the leading coefficient presented. Sometimes you just draw arrows. Sometimes, though, they're going to use vocabulary such as rises to the left, which means going up here, and rises to the right, which means goes up here. And sometimes you see this kind of wild-looking infinity notation. So let's take a moment to explain this in case you see it. As x approaches negative infinity, that means as you're leaving the graph on the left-hand side, because x is left to right, and if you go to negative infinity, it means you're going a long way forever to the left. So this means on the left-hand side, and then y approaches positive infinity, that means you're going up forever. So this piece right here is synonymous with this left arrow going up. As you go left, you're going up is what this means. And then it stands to reason that x approaches positive infinity. That means going to the right forever. You're also going up. So that's the reason we have the right arrow going up. Now that's just even positive. You could apply those same kind of looks for all 4 of those. Let's look at a couple examples. Describe the end behavior. Remember, we only care about the leading term, okay? Because over time, it's a bit of a calculus concept, but as x gets very large, this term is going to really take over and kind of overwhelm the other terms. So it decides which way the graph goes. So this is an even negative. Remember, we don't care that 7 is odd. That means nothing. We look at the degree. The degree is even, and the leading coefficient is negative. Okay, so if you remember the chart, even arrows together, so they're going to go in the same direction, and negative means down. So they're both going down, or those other ways you might see. You might see falls to the left, falls to the right. And you may see, again, this wild notation. This time, as you go left, you're going down. That's what y to negative infinity means. And as you go right, you also go down. So they're both down there. And there's the example of the graph, or the look at the graph here. You're going down as it leaves the screen. This is off of Desmos. Here's the origin. And you're just going to keep going down forever on the left and on the right. A second example, describe the end behavior. Be careful. Make sure you grab the leading term. It's not guaranteed that your polynomial will be in standard form. So make sure you take the one with the highest variable exponent. This is odd positive. Odd because of the 7. Positive because of the 5. The fact that 5 is odd is not relevant here. It's the 7 being odd that makes it odd. If you remember from your chart, or you can think even arrows together, so odd arrows are apart. The positive hand is your right hand, so your right hand goes up. Or you may see, again, that other notation, in this case, falls to the left, rises to the right. Or as you go left, you're going down. That's the reason that's down. As you go right, you're going up. That's the reason that one's up. The leading coefficient test.